charities, etc., even Comic Relief. So I went to see Comic Relief yesterday, and we're talking about how we can help them build a charity community cloud, effectively. Yeah? And the reason that they're so interested in that is that their average usage, day-to-day running of their business, is only 5% utilization. Is that on that one day, Red Thursday in March, for 3 hours, and they're trying to capture 40 million or whatever it is, pounds worth of donations. But they don't call it a spike, they call it a slam. Okay, they just get slammed with requests, all these transaction requests from PayPal, WorldPay, and whatever. So they're really up for it. So we'll sort of help them build a cloud with the appropriate control mechanisms, and they can sort of spill out to various different public clouds as needed, and we'll build a marketplace to allow us to trade, or for those public clouds to donate CPU cycles, to a charity and so forth. So it's a pretty cool project, but really, really interesting. Incidentally, I saw, is it Brian May, the guitarist? Yeah, I saw him. His hair is bigger in real life than I've ever, you see on TV. It's actually massive. Okay, I hope you appreciate my slide graphics here. Spent ages doing this. That's what you get from the vendor, slick slides there. So time value of money, this is an obvious one. Yeah. So it's essentially the longer it takes you to spin up or spin down capability to react to a business need or whatever, costs money. So it's all about this is where the orchestration, intelligent orchestration comes in, real-time capacity management comes in to help us deliver those capabilities faster and more seamlessly. And then finally, the last one is really sort of an adjunct, if you wish, sort of enabling innovation. So, in the past we would have code developers, and we call them, server huggers. They like to have their CaaS CPU underneath the desk, doing their coding, everything is there. Actually, if you amortize the costs over a period of time, actually that's a pretty expensive way of doing things, whereas if you can actually have them utilize resources in the cloud, use them when they want, run their algorithms, spin that down, and become much more effective from an economic viability. And that actually helps. The net of that is it helps, for example, venture capitalists really reduce their risk. So they can take on a new startup, they can go to a cloud, use that cloud. A good example of that would be a company called Zynga, Z-Y-N-G-A, Zynga. It's the mobile gaming. Yeah. So what they did was they went to Amazon first when they first started. So basically, they didn't have to spend a lot of capital buying lots of compute equipment and so forth. They just used the Amazon cloud. And what they did, once they reached a fairly large size, they had the revenue coming in. They then built their private cloud, shifted the base workload into the private cloud, and then spilled out to the Amazon. So they sort of did a sort of an outside-in job, if you wish, rather than most people start with a private cloud and go out, so inside out.
So you think you could have saved OnLive from falling apart then? Because OnLive is the console in a web server, and they said that they spent all their money on buying their own cloud, and that's why they went bankrupt.
Potentially, yes, because from an accountancy point of view, it's all about when am I going to get that money? Yeah, I can make the investment, but how fast will I get that return? Yeah, and that's really critical to anything. That's cash flow, essentially, right? And that's what kills most businesses. So yeah. So I love this cartoon. It's probably one of my favourite cartoons. I'm just a bit sad, I know, but it really illustrates the point so well. Yeah? So we all think about technology all the time, and that's fantastic, and we need innovation there. But it's the application of that technology and the uses of that technology that actually gets the funding, as you know. And this just to the point, sort of business process side. You can't just throw everything, automate everything, overnight. You expect complex process problems to go away in the business. They still exist. So you have to do the hard work, you roll up your sleeves, and figure out how you optimize your processes in this new world order. So, building a successful cloud is all about driving standards, building modular components that you can put together. Those modular components to deliver a particular service. That's technology components, the service components, all together. That's also things like workflow, for example, as well. So reusability of those areas as well. And that creates a lot more efficiency. Rather than reacting to need, we're predicting need. So what you really need to do there is define a really good service strategy over time. So it's very much an enterprise architect approach to delivery of IT. Publishing marketing services. Well, if you think about it, this web page becomes your interface to the outside world. So if you have successes, for example, publish them. If you're reducing costs, all that kind of thing, right? But also if you want to market new services, etc., that's the way to do it. And there's lots of experts around that, far better than I can do. And probably Google guy will be much better at that than me. Driving adoption and consumption. You don't want to be an owner of a dark cloud. Yeah, so you have to use carrot-stick methodologies to get people to actually use these new resources. And here's a really important one, governance. So this is a key area. So I'm doing a bit of work with the Cabinet Office and around government cloud and public services network. How to sort of turn that into a cloud as well, a service, IT as a service, or network as a service rather. So policy and governance is really key here. It's how do you have the policy, appropriate controls embedded in the infrastructure, in the architecture, to actually ensure compliance to whatever regulatory need there is. So that's actually, in a way, that's one of the key inhibitors of companies adopting cloud services. It has to be easy. That's why Apple is so successful, as we all know. It's making it so easy to utilize their services most of the time. I have a few problems with that, but and finally, you're basically a big inventory store as well. You've got to track who owns what, when, and where. Yeah, you are the DHL, the UPS, effectively. So let's shift gears slightly now. We're going to talk a little bit about how cloud relates to networking. Talk about some interesting areas of development in networking. So obviously Cisco's DNA, the company I work for, is in networking. So we're very much interested in understanding what the sort of the broader use cases are. So we have service providers who are all about trying to optimize the delivery of services, and some of the greatest challenges they have is that exponential, not exponential, but linear growth, but very rapid growth of traffic, and particularly for mobile networks, for example, is a key area. Also, how do you derive analytics out of the network? So, for example, I was talking to the CTO of Vodafone, global CTO, and he was very excited. An Irish company came up with this idea, how to actually capture data off a mobile phone to capture what they call footfall traffic of passing shops. And if you combine that with the information that mobile operators have about their subscribers, with that geo-proximity information, they can start combining who does what, etc., and start thinking about near field communications as well. So as I walk past the phone shop or whatever, somebody will go, "Hi Greg, we noticed that you've got 2 months left in your current contract. Would you like so and so? The iPhone 5 or probably the iPhone 16, but I don't have an iPhone, by the way. One of my life's regrets. Okay, so data centers, again, it's very much consistent look and feel across here in terms of some of the requirements, particularly around programmatic APIs. The ability to expose value or richness from the actual infrastructure, from not just the software, but the hardware infrastructure underneath as well. The idea is, there's no one size fits all, but actually we can start to think about efficiencies of collapsing lots of different services onto a single platform. And Cisco does a lot of work there. And in order to achieve that, we need intelligent networks to essentially help us manage the scale and complexity and the speed at which that happens in a much more efficient way. So, for example, a lot of security today is done by looking at IP packets. And you have these devices called firewalls that look at these IP packets, and look at what we call 5 tuples, essentially, 5 different headers of an IP packet, to see where it's come from, where it's going to, what the application type is, etc., etc. A couple of problems with that. Number one, there's sort of a collapse of different protocols moving to sort of port 18 and port 443, or that's SSL and HTML. So it's HTTP, sorry. And essentially, So what we actually need to do is actually go deeper into the packets. But also, that sort of paradigm of checking network headers doesn't really relate to the usage of who actually owns that flow or created that flow and what service that flow is actually going to go and use. So we could actually start putting embedding semantics into the network headers. And can actually describe groups of interest, if you wish, and start filtering on those groups of interest rather than arbitrary network packets which don't have any real meaning. Other really interesting areas are sort of integration of silicon and photonics, as an example. The collapsing of multiple layers of the network. So we have, I'm sure most of you know about OSI stack and all that sort of basic stuff, but you have optical networks, you have layer 2, layer 3 networks. So what's actually happening is that we're taking IP, we're putting it directly over optical networks now, and we are defining interfaces between those layers and using intelligence in the IP layer to actually control and optimize the lambdas and circuits at the optical layer. That's quite an interesting area because that reaches right down to the sort of base level of the network infrastructure, trying to optimize it for delivery of scale. The important thing here really is about open standards, or otherwise achieving parity in an architecture. So you can integrate different components from different vendors rapidly, quickly, with lower risk and all the rest of it. So, autonomic networking. This is a key area, which is an emerging area that's turning up now. Some of my colleagues have just written a paper, a framework for autonomic networking. And essentially what we're trying to do is that we've got this complexity cube, right? So the amount of human effort to make changes, to spin up, to connect, to bring down the service, network management, and network nodes. So the amount of network management points you need, and associated with the number of nodes. What we want to do is reduce the amount of human effort required to configure those and manage the life cycle of equipment, but also reduce the number of management points. And that's essentially what we call autonomic networking. From a high level, that sounds rather obvious and very simple, but actually making that happen is very complex. It's all about understanding what level of abstraction we build into these architectures. Particularly because you need to have a local view, but also have a local view within a global view of what's happening in the overall network. Yeah? So it's a bit like you wake up one day from a coma and you're wearing an Arsenal football strip. And you may not like Arsenal, I do apologise, but the idea is that you turn on, you've got to wear this football strip, but you've lost your memory, you have no idea you're a footballer. And someone says, go onto that pitch. And you go, oh, okay, I've got to, and what do I do? Yeah? Someone's going, well, you're so-and-so. You may think you're Thierry Henry, for example, but actually they always call you donkey because you're Tony Adams and you're just a plotter central back footballer. So the idea is someone's going to teach you, what your role is, within the team, what the objectives of the team are, etc., etc. So you have to understand the global space and understand your local role within that team. So that's the sorts of problems we're solving with autonomic networking. The idea is that we can bring a bit of equipment, connect it in, basically auto configures, it can also protect itself, etc., etc. These kind of things. Another area of interest, and it's a bit of a busy slide, next slide clarifies a lot of what I'm talking about, is essentially going back to the compliance and governance piece I was talking about earlier. So if I take a workload, which is an application, and I put it into the cloud, what does that workload need in order to be compliant and regulated? What controls and capabilities do I need to put around it in order for that to happen? So do I need a certain type of firewall, for example? Do I need an XML firewall versus a regular firewall? Do I have to have data that's encrypted on disk? Or do I have to have load balancing, availability? All of these kind of things that actually make that service viable to be put into that particular cloud. So what we do is actually build abstraction models that abstract the service from the underlying infrastructure itself. So the idea is that essentially, if we take a picture here, it's not the best, I'll explain it. Imagine this is what we call a router, okay, that will connect to the wide area network. It can either be a VPN or the internet. and you want to connect it into the data center, which all of these elements reside in. So you've got, various switches, you've got load balancers, you've got firewalls. And essentially, what we want to do is create what we call a service chain in order to support a particular workload. Okay, so we can model that service chain and then programmatically stitch together all the elements in that service chain as we go forward. And in fact, we're doing stuff beyond this. So we're actually putting in additional control planes and so forth to allow us to completely ignore, effectively, the underlying infrastructure itself, either it be logical, physical, or virtual, and actually be able to route traffic between service nodes for various policy enforcement treatments. So you get that complete abstraction between the layers. So you get a lot more flexibility and so forth. And we can do this. So we can build different sort of topologies. So if you have an application that has a web access and database, 3-tier architecture, we can build that. If you just want a simpler topology, we can build that. We build this all into meta models, XML meta models. And the key here is not the language you use, but the processing engine behind it, but also how we construct these models in the first place, and how flexible you have these models moving forward, because they need to be sustainable in the long run. Just a little bit around software-defined networking now. That's the hot topic in networking. So the idea in the past is that you have a box, a router, switch, whatever. If you're American, you say router. You've got to be a bit careful when you're in Australia and you say routing. It's a bit dodgy. But anyway, I learned that to my cost. So we have a box here. We have a data plane, we have a control plane, very simple. And typically, you have vendor-specific northbound APIs. And essentially what happens is each of these nodes builds up an understanding of the network topology by talking via different protocols to different boxes. Now, to change that sort of what's the hot topic today is what we call software-defined networking. And essentially what you're doing is you're taking data plane boxes, but you're divorcing the control plane away from that box and moving it central. And then you're using a protocol to connect the two from the control plane to actually program the hardware to do stuff. Now, one thing is something called OpenFlow. Anyone here doing anything? Are you working with OpenFlow at all? Done any work? No? Well, I mean, to be honest, we've been here before. It's just another ephemeral protocol, right? It's, we've had COPS, we've had diameter, we've had lots of different protocols around. So, but OpenFlow is quite interesting from the perspective that you actually can create effectively overlay networks on the data plane. So you can segmentize the network for different usage and so forth. You can build end-to-end cards across the network for priority traffic, stuff like this if you wish, which is completely divorced from any other learning. And what I mean by that is you can actually, we think, if you look at the latest OpenFlow spec, which is 1.3, so 106 pages of riveting reading, essentially the idea is that you can combine the two. So you can have local and you can have global kind of views. One of the advantages of having this sort of centralized control plane is that you can model the end-to-end network in a central location, rather than having to repeat that many times in many different nodes, which costs you more money to do, basically. So it's interesting, I was doing a presentation to a VC community not long ago, and one of the guys, was this Californian guy who's instrumental in funding companies like Google, for example, and came up to me and goes, yeah, I think it's really interesting, SDN. It's like the analogy he made, it's like everyone wants, is all getting all excited because they've got this kettle, and what they can do now is change the lid of the kettle to something slightly different. They get all excited about that. It was funky, cool, wow. But the reality, it's just a kettle. Right? So anyway, so it's an interesting debate. People like to get excited about stuff. The corporate positioning from Cisco is this is about evolution, not revolution. Because a lot of people have investments in existing gear, existing application architectures and so forth, and you need to move them. The real pain, if you can solve the real pain, is the migration. If you get someone from A to B, from current state to future state, then that's where the money is. Okay. Just a word on the standards, around cloud. It's still emerging. There's lots of different bodies out there doing different things, standards bodies, that is. Not people, but not people as well, I guess. But we have, people working. So Cisco is an American company. We work with the American delegation into the ITU, which is part of the UN, defining, architectural models, the ontology related to those architectural models. We also work, with lots of different technical standards bodies, the IEEE, the IETF, ONF, lots and lots of others I can bore you with. But essentially, there's lots of pieces, but there's still we still haven't got sort of the holistic picture put into place. And essentially, the challenge we have is being able to move workflows from one cloud to another, because essentially, the ambient management environment is going to be different in different clouds, right? So how do you hook up that workload to the management environment effectively? But this will be solved slowly, and there's also emerging de facto or pseudo standards. You can tell me which word to use. I haven't really looked into the definitions, but effectively, what we're seeing is open source communities like OpenStack. Here, anyone play with OpenStack at all? Yeah? Okay. Okay, so it is beginning to mature now. We've done, as a company, done a lot of work on the networking side, and we've built the networking plugins, if you wish, and the plugin framework as well for that. And the fulsome release will be released a bit later this year. Actually, it should be now fulsome release. So, and that's improving over time. So that will be more.